Good evening, boys and girls and Cougar parents. Let's take another look at multiplying exponents. And keep in mind, you might want to do this on a separate piece of paper. I have a lot of problems and not a lot of room. Let's do a couple together right now. Take a look at number one. Okay, number one, we have 2 to the third power times 2 to the third power. Our bases are the same. So when we simplify, the base will stay the same. It's 2, and I just add my exponents together. That gives me 2 to the 6th power. Now let's just prove this. Now some of you are saying, well, shouldn't I multiply 2 times 2 and get 4? Well, you are. Okay, we're going to do that 6 times, okay, but we're just writing this in exponential form. See what I'm really doing here, just a reminder, I'm adding the exponents. That's just a shortcut. But in reality, what I'm doing is 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 1, 2, 3, 4, 5, 6 power. See, I can do it the long way and prove it. Either way, I'm going to get 2 to the 6th power, or I can realize there's a pattern here. Okay, I'm going to be multiplying 2, this base, using it as a factor 3 times here, and then 3 times as a factor here, altogether 6 times. Okay, now let's look at number 5. Number 5, I have 4a times a, and I know really that there's no, it's not, isn't written per se in exponential form, but I know that anytime I just have a variable a, that it's really to the first power, and this is really to the first power. So now I look at it as 4 times a to the 1 plus 1 power. I'm just adding those two exponents. That's how I got that. So altogether I have 4 times a to the 2nd power. And if you don't believe me, write it out in expanded form, and sure enough, you'll see that you have 4 times a, which is 4 times a to the 2nd power. Let's look at this one. Back and got rid of the exponents. I'm back to using numbers, and my base is 2, so my base stays the same. I add my exponents up. I have 3 there, plus a negative 3, plus a 4. When I add this up, a 3 and a negative 3 is 0, plus 4 is 2 to the 4th power. Okay, boys and girls, let's jump down to number 13. Now, 13 definitely looks very intimidating, but if we keep the, if we do it step by step, the other thing too I would suggest with a problem like this, you don't have to, but you might want to reorganize. You might want to put your kind of x's, order them together, and your y's together. And you can do that because the only thing we're doing here is multiplication, and since we have what's called the commutative property multiplication, it says that when you're just multiplying, there is really no order of operation, since the only operation you're doing is multiplication. So you can move things around, and it doesn't change. It won't change your answer at all. So what I would do is, first of all, well, let's look at this. I go through here. I have 4x to the negative 4th power times y to the negative 3rd power times x times y times 4 times y to the 3rd power. And let's remember here, even though there's no exponent, x is really x to the 1st power. It's kind of silly to write that down, but what we're doing right now, it's very helpful, and y is y to the 1st power. So first thing I'm going to do is take a look at my coefficients, and I've got a 4 here and a 4 all the way over here. So I got 4 times 4. Put those together. Okay, then I'm going to put all my x's times x to the negative 4th power, and then I have times x to the 1st power, and that's it for the x's. And then when it comes to y, I've got y to the negative 3rd power, and I've got times y to the 1st power right there, and then I've got y to the 3rd power. You might say, well, what about the 4? Well, remember I put the 4's up here. I put the coefficients together, and I'm just multiplying straight through. So 4 times 4 will be 16. And then I've got times x, and let me add up all my exponents, to the negative 4 plus 1 plus negative 3, okay, times y, oh, wait a second here. Okay, I only have two x's. I have x to the fourth and x to the first. So that's it. Times y to the negative third plus that one there, and then I have an exponent over here, which is 3. Okay, so now I've got 16 times x, and a negative 4 and a positive 1 will be a negative 3, times a y, and I've got a negative 3, and then a positive 3. They cancel each other out. That's 0 plus 1, which is y. Okay, so now I need to ask myself, well, I got 16 up here times x to the negative third power. I know that when I have a negative exponent, it's repeated division. So that becomes that times y. Let's clean this up a little bit. Let's just multiply straight through. 16 times 1 times y is 16y over x to the third power. I had to catch my breath there. Let's go to number 18. And if you have any questions about this, please bring your questions in tomorrow. Okay, here I've got a negative 2 times a negative 2 to the negative third power. So my base is just a negative 2. And then remember I got a 1 there. And when I take a look at all my exponents, I've got a positive 1 here and a negative 3 there. When I add them up, I've got a negative 2. And I know that this really means a negative exponent here. It means I'm doing repeated division, so it's 1 over a negative 2 to the second power, which this is going to be 1, and negative 2 times negative 2 is 4. And that is my final answer. Okay, let's take a look at number 21. Now, 21, I have to be honest, is a little tricky, okay? When you look at it quick, it doesn't look that difficult compared to most of the problems. It's 2x to the negative, well, it's 2 times x to the negative first power times y to the fourth power times a negative x to the third power. Now, here, this is what's easy to miss. Okay, see, right here, look at our coefficients. You might say, well, this doesn't have a coefficient. Well, actually, technically it does. This has a coefficient of 2. This has a coefficient of what? Negative 1. Okay? Because this is negative 1 times x cubed. Okay, and if we do that, it'll make things a lot simpler. Then over here I have a common base of x with an exponent of negative 1. Here I have an exponent of x with 3, so I add those exponents. That's where I get that from. Okay, and then I have finally y to the fourth power all by itself. Okay, so now let's work through this. I take 2 times a negative 1, and that'll give me a negative 2. I've got x to the negative 1 plus 3 exponent, or power I should say, and that's going to be x to the second power times y to the fourth power. When I put it all together nice and neat, I've got a negative 2x to the second power times y to the fourth. And that is my final answer for number 21. Now 23 is a mouthful. I've got 2 times x to the third power times y to the fourth power times 2 times x to the second power times y to the negative second power times 2 times x to the negative third power times y to the negative second power. Okay, let's take all of our exponents. Okay, I've got 2 there, a 2 there, and a 2 there. Okay, 2 times 2 times 2 is 8. I could have written that as 2 to the third power. I chose not to. Let's take care of our y's next, and let's do a different color for y's. Maybe this will help some of us that might be a little confused here. There's a y. I've got 3 y bases. Okay, and that's y to the fourth power plus y to the negative second power. Okay, and then another negative second power plus, okay, and then times my first x right here. Let's go with another color. Got all my x's. Okay, and then that was my y's. Now I got x's. So I got an x there, an x there, and an x there. Okay, so here I have x to the third power, so that's exponent, then I've got an x to the second power, and I've got x to the negative third power. Okay, when I add this up, okay, let's bring it all down. I've got 8 times y, and if I add up all my exponents, I'm going to get y to the 0 power. Yep, to the 0 power, times x to the, well, here I have plus 3, here I have minus 3. They cancel each other out, and I'm left with 2 to the second power. Now I know that anything to the 0 power is 1, so y to the 0 power becomes 1 times x to the second power, and I end up with 8x to the second power. Let's flip over to the other side. We're going to do 2 more practice problems together, and I think you can handle the rest on your own. Okay, here we have the product of 5 times x to the negative third power times y times the product of 6x to the 7th power times y to the negative 4th power. Okay, well, again, we can read, this is all multiplication. So I have a 5.
It's 5 o'clock.
Times 6. Okay. There are my coefficients. Times x. Okay, and let me just add up all my to the negative third plus 7. Okay, I got my x's from there. And then I have my y's times y. This is really to the first power, remember? To the 1, and then I have to add the negative 4th power there. Okay, 5 times 6 is 30. And then I add up my exponents. A negative 3 plus a 7 is x to the 4th power times a y. And then a 1 plus a negative 4 is a negative 3. So this is going to end up looking like 30x to the 4th power times, and y to the negative third power is really repeated division, so it's 1 over y to the third power, which when I clean that up, it's going to look like 30x to the 4th power over y to the third power. Now, ooh, this is a nice problem. We're going to bring in a little geometry. Now, hopefully remember your area formula. I know that area for a triangle is equal to base times height divided by 2. Now you may have learned 1/2 times base times height. I just like writing like that. So my base is 6x to the second power. My height is 9x to the third power. Okay. And then I divide all that by 2. Okay. 6 times 9 is going to be 54, and then x to the second power plus the third power is going to be the 5th power. I'm not even going to write that. And then I take all that, divide that by 2. 54 divided by 2 is going to be 27. X to the 5th power. And I am done. And you're not, though. As always, I hope that was helpful, and if you have any questions about the remaining problems or the problems that even I went over just now, please bring those questions to class. See you later. Bye-bye.